Alrighty, friends. This is another help tutorial for a question on the Atwood Machines Lab. So this is for question number 7, where you are comparing your data. And I want to state first off that I've had a lot of questions about this question, and that tells me, as your teacher, that I worded this in a way that was not very accessible or understandable to you. So that is on me, and I do apologize for that. And I hope that this help tutorial can help clarify those questions. All right, so let's frame this question first off. So let's actually go back to when you took chemistry. So if you remember in chemistry class, a lot of the times for a chemical reaction, you would compare what you expected to get based on what you started with to what you really got. So the examples I have here are, if you are combining some molecules together, based on how much you start with, you expect a certain number of products, right? Or in a more real-world example, if you start with certain ingredients, like to make one cake, you expect that you can make one cake, right? If you don't have enough ingredients for 2 cakes, you can't make 2 cakes, right? So we're comparing what you expect to get versus what you really got. That's what number 7 is asking, just for a physics problem. So, experimental versus theoretical data. Experimental data is the data you get from doing the experiment. These are the actual numbers and values that you get from reading a ruler or a balance or other form of instrument. So in this case, for our virtual lab, the experimental data is that big old data chart from the simulation. We are counting the simulation as the experimental data. Pretend like you did the simulation yourself and took those measurements. The theoretical data is the end result you would get in a perfect world. So, experimental is what you actually got, and theoretical is what did you think you should have gotten? So, in the Atwood simulation, for the experimental data, again, this experimental data corresponds to the values that spit out when you ran the simulation. Specifically, I'm asking you to compare the acceleration values. So, from your experimental data, how do you calculate acceleration? Well, if we look at this plot here, which I asked you to actually plot as well, we have velocity versus time. Y'all take a second. What does the slope of this line correspond to? So what is change in velocity over change in time? The slope is acceleration. So, if I sat you down with graph paper and scratch paper and said calculate these values by hand, with a calculator and a pencil, you would calculate the acceleration at every time point based on the slope equation. Velocity 2 minus velocity 1 divided by time 2 minus time 1. This is what I ask you to do in your spreadsheet. So calculate these experimental accelerations using the spreadsheet. I do not want you doing this by hand. I want you to get practice with using spreadsheets, right? This way, you can just plug in a formula once, and it'll calculate the rest for you. All right, so the theoretical data then. Your theoretical data, your theoretical acceleration comes from your derived acceleration equation. This is your answer to number 4, your final answer. It's this equation right here. This equation says that in a perfect world, all of my experimental data should give the same acceleration that this equation spits out. So this equation right here, this theoretical acceleration, is based on the masses you start with in gravity. So this is your theoretical acceleration value. So, step by step for question 7. In 7a, I'm asking you to look at your experimental acceleration values. This is your spreadsheet. In 7b, I ask you to calculate your theoretical acceleration. So that's that derived equation. Then in C, I'm asking you to compare, did you get the same results? So, overall, the question I'm trying to ask you here is, did you get what you expected to get? Again, if you start out with a certain set of masses or ingredients or whatever you're looking at, did you get what you expected to get? That is what number 7 is all about. All right, if you have other questions, let me know.